If the sample size is big enough, many frequency curves end up with this kind of shape, this kind of bell-shaped curve, and we call this a normal distribution. One feature of the normal curve is that it's always symmetrical about the mean, right here. The other thing is that for a normal distribution, the mean is actually the median, which is also the mode. The normal curve always lies above the horizontal axis, but if you look at the tails here, they never touch the axis. And more importantly, it measures that 68% of all data lies within one standard deviation from the mean. So standard score would be between -1 and 1 for those data. And 95% of data lies within 2 standard deviations from the mean. And in other words, those data with standard scores are between -2 and 2. And 99.7% of data lies within 3 standard deviations from the mean. Okay, so the standard score for those data are between -3 and +3. So let's use these information to do this problem. So in the survey, the traveling times of buses from Yuen Long to Central are normally distributed. The mean is 70 minutes. Standard deviation would be 8 minutes. So we've got this information, and we want to find the percentage of buses with traveling times between 62 and 78 minutes. So to do this, we have to express the 62 and 78 in terms of the mean and the standard deviation right here. So we recognize that 62 is actually 1 standard deviation below the mean, while 78 minutes is 1 standard deviation above the mean. And so if we refer to the normal graph here, within 1 standard deviation, right? And that corresponds to 68% of data. And so the percentage of buses with traveling times between 62 and 78 minutes is 68%. So what about 54 minutes and 78 minutes? What's that percentage? Again, we express these two numbers in terms of mean and standard deviation. So we recognize that 54 is 2 standard deviations below mean and 78 is still 1 standard deviation above mean. We could actually get this number for this portion by using the 95% here. We could do that by subtracting 68, which is the middle 2 portions, from the 95 here, right? So that gives us this part and this part. But because they're symmetric, then we divide it by 2. So that's how we got 13.5. And so the percentage would be this portion plus the 2 portions here, which is 68. And the answer would be 81.5%. So what about the percentage corresponding to below 54 minutes? We remember that 54 is actually 2 standard deviations below mean. But this time we want this part, this tail of it. So 54 is right here, 70 is right here. In order to get this tail, we want to take half of the whole thing, which is 50% due to symmetry, and subtract it by this portion. But this portion is just the half of 95%, right? And so the percentage of this tail would be 50%, this whole half, minus this green portion, which is 1/2 times 95%. And that would be 2.5%. Now part B, if there are 600 buses in total, how many buses have traveling times between 54 and 62 minutes? So of course, we still want the corresponding percentage. And we know 54 minutes is 2 standard deviations below mean, and 62 is 1 standard deviation below mean. So by recognizing the graph here, this is the portion that we wanted. And this percentage could be obtained by taking this 95% minus this 68% and then divide this by 2, which gives 13.5% for our portion here. And so the number of buses that we wanted is taking the total number times the 13.5%, and the answer would be 81.